Hello, students. Welcome to our second class of online learning. Okay, so I hope you have done all the exercise, right? And try all the exercise. Now we look at what is discriminant. So in a quadratic formula, we have x equal to minus b plus minus square root b squared minus 4ac over 2a. We notice that simplified the set may yield a real number, 0, or imaginary number. So we give an example, for example, okay, if your b square is 9 and your 4ac is 8, so 9 is greater than 8, so inside the square root, right, we give you a positive number. So right, the answer or the solution or the root will be a real number. Okay? If your b square equal to 4ac, which is 4 equal to 4, right, you will get 0. So you will get right, 2, right, same root, right? And then if you have b square is 16 and your 4ac is 20, so b square is less than 4ac. So when you solve your square root, you will get a negative square root, right? Square root of negative value. So this will give you the complex number. Okay. So b squared minus 4ac may cause a simplification of minus b plus minus, right, square root of b squared minus 4ac over 2a to get, right, two distinct real root, okay, two identical number or two complex number. Okay, therefore, right, b squared minus 4ac is a discriminant. Okay, since it's discriminant, the root of the quadratic equation. Okay, so this is a summary of b squared minus 4ac. Okay, when you substitute, okay, you will get either greater than 0, okay, equal 0, or less than 0. So if greater than 0, right, the equation have two real root. Right, the equation have one double real root if you equal 0, and when it's less than 0, so the equation have two complex imaginary root. Okay, now we come to example 6. So without solving, determine the nature of the root. So 3x squared plus 2x plus 7 equals 0. So we list out all the coefficient, the quadratic coefficient, linear coefficient, and the constant c, okay, and substitute into the discriminant, right? And we will get either positive, right, or equal 0, or less than 0. So for this example, we get less than 0. Then we have two distinct complex imaginary root. Okay, so if you draw the graph of the function, right, the function does not, right, pass through any value in your x-axis. So that's why your b squared minus 4ac less than 0. So if your b squared minus 4ac is greater than 0, so your graph, right, pass through the x-axis 2 point, right? And if your b squared minus 4ac equals 0, so your graph only touch the x-axis at 1 point. Okay. So Okay, after you understand the discriminant, so you can try this exercise 5, okay, by yourself. Okay, the answer is given. Okay, let's just go into another subtopic, inequality. So this is a learning outcome that you can read yourself later on. Okay, so what is inequality? So inequality is a relationship of two quantity or expression having a different value. Okay, using okay, not equal, right? Simply state that the two expression differ without making comparison. Right? As with equality, inequality can be true or false, right? With or without condition. Okay? Example, okay? 2 is not equal to 4. So everyone know, okay? It's true. And 2 is not equal to 2. Okay? Everyone know this statement is false. Okay? While x is not equal to 4, right? It can be true if your x value, right, is other than 4. Okay. The more specific type of inequality compare the magnitude of two quantity. There are, we have two types. Okay, strict inequality, right? So A greater than B, okay? A less than B, okay? Very strict, okay? Okay, non-strict inequality, right? We have A greater equal B, right? Why is not non-strict equality? Because A is greater than B, right? And then or equal to B. Okay? So can you make a difference between strict inequality and non-strict inequality? Okay, so similar to equation, right? Equality, we have a property for inequality as well. Right? So transitive, okay, this one is quite simple. So A greater than B, B greater than C, then A greater than C. Okay, so for example, if your 3 is greater than 2, okay, 2 is greater than 1, okay, then 3 is greater than 1. Okay, so convert, okay, 3 greater equal to 2. If you want to convert it, then we can say 2 is less than equal to 3. Okay, so this is convert. So we change the left hand side to the right hand side. The equality sign also change. For additional and subtractional, the inequality doesn't change. Right? So for example, 3 is greater than 2. So we plus 1. Right? So 4 is greater equal to 3. Okay, so your equality sign not changing. However, for multiply, you have to be careful. For positive, right, this is not changed. Okay, but this one, okay, the sign is changing. Okay, for example, you have 3 greater equal to 2. When you multiply with negative 2, so 3 times negative 2, 2 times negative 2, so the sign is changing. Okay, because this one you get negative 6, negative 4. So negative 6 is smaller than negative 4. Okay, can you see? From greater equal than, okay, after multiply with a negative value, okay, the end result, okay, the value actually is less than equal, right? The sign is changing. Okay, so additive inverse. Okay, so if you multiply with negative 1, okay, so this one something like the multiplication. So if you have 3, okay, sorry, just now I accidentally pressed the sum button. So if you have 3, right, greater equal to 2, if you multiply with negative 1, you get negative 3, negative 2. So the inequality change. Okay? So how about multiplicative inverse? Okay? If your A multiply B is greater than 0, that means your A is 3, your B is 2. When you multiply, right, you get 6. So you get greater than 0. Right? So if A greater than B, right? So 3 is greater equal to 2. When you inverse it, right, 1 over 3, 1 over 2. So what can you see? It's no longer greater than equal, but you change to, the end result change to less than equal. Okay, so a student, you can try the rest, for different type of example. Okay, now we go to linear equality. So linear equality is a univariate inequality that can be written in one of the following form. We have greater than, less than, greater equal than, less than equal than. Okay, so we look at some of the standard form. We have the linear expression ax plus b, inequality sign, and 0. So we have linear term and free term. The coefficient is a linear coefficient. The free term is constant. So this is quite similar to your in quadratic, quadratic standard form. So solving a linear inequality. So any form of linear inequality can be expressed such that only the unknown remain on one side of the inequality by applying the property of inequality. And it is not exactly necessary to write in the standard form in order to solve the equality. So you don't need to write in the standard form when you solve the inequality. So we look at example 7. Okay. So we want to neutralize the 4 at the left hand side. Okay, so we minus 4 both sides. Okay, then we manage to neutralize the value 4 at your left hand side. And then right, we divide everyone with negative 3. So remember, so any multiplication and division, divide with a negative value, right, the sign is changing. Okay, the sign is changing. Yeah, highlight here. Okay, this one. You see? Then you simplify. Any value is greater than negative 7 over 3. Make the statement inequality true. Therefore, this is the solution. So a change of inequality can also be solved using property of inequality. Be careful to make sure that each segment of the inequality is treated equally. Okay, so for example, if you have in between negative 6 and 2, and then the function 2x minus 4, right? So the equality if you want to neutralize the negative 4 in the middle, so we plus 4, right? Left hand side, middles, and right hand side. So after simplified, right, we want to simplify the 2, multiply 2, right, by dividing every term with 2. So this one does not change your inequality to greater than become less than, okay, because your value that you divide is positive. After you simplify, so here is your answer. So far, we have expressed a solution in the linear inequality in form of inequality. Okay? So there is also another way to write your solution of inequality using the interval. Right? So interval is a set of all number between two number. So interval can also be represented graphically using number line. Okay. So this is the uh, interval notation. Okay. So just now what we have learned is we write our answer or our solution in inequality form. We can also write our answer in the interval notation form. Right? So very simple. Right? So if you have greater or less than, right, without equal sign, so you call this is open bracket. So if you have equal sign, right, we use a square bracket, so we call this a closed bracket. So open bracket for non-equal sign, closed bracket for equal sign. So we can use the graphical representation, right? So another word, this is number line, right? So if without equal sign, empty dot. Okay? If with equal sign, full dot. So same thing apply for the next two. All right? Okay. Uh, if you have one-sided, right? So you look at the direction of the equality. Right? So this one we always told it this is the arrow. So this one arrow pointed toward positive infinity. So your interval notation, right, is from a to infinity. And then we remember that, right, at the infinity and negative infinity, always open bracket. Okay, don't write close bracket, right? Don't use the uh, square, right, bracket, right? Use a round bracket. So the number line, empty dot if you don't have equal sign, full dot if you have equal sign. Okay. Okay, now we go to example 9. Okay, solve the equality in between negative 5 and 1. Okay, 4 minus 3x over 2. Okay, so we multiply by 2, right, to simplify the denominator of 2. Right, so all the term we multiply with 2. Right, here this is what you get. Then we want to simplify the or neutralize the value of 4 in the middle. So by minus 4, okay, or subtract 4, right? Left hand side, middle, and right hand side. Then, okay. So can you see the red color that I put? Okay, why this direction of the inequality change? The sign of the inequality change? Because we divide or multiply a negative value. Okay, that's why the equality direction change or the equality sign change. Okay, so if we want to write it from using the ascending order, because this is not the ascending order, right? Previously this is not ascending order, so this one is the ascending order. So ascending order means from small to large, right? So we just rearrange the equation, right? The small is 2 over 3, the last one is 14 over 3. Uh, so this is an inequality solution if we want to write in interval notation. So this is how you write your interval notation. So the reason we want to arrange the inequality um, in ascending order, because later is easier for you to write in using the interval notation, right? So number line, okay, number line also we ascending order, right? Small to large, right? The small one at the left hand side, the large one at the right hand side. Okay, so empty dot without equal sign, full dot with equal sign. Okay, so here is the example exercise 6 that you can try yourself. Okay, okay. Next, we look at solving using table of sign. Okay, supposedly we have the expression of x plus 1 and the expression evaluate to 0 if x equal to negative 1. Means that we find what is the x plus 1 equal to 0, and then we get x equal to negative 1. So the 0 of x plus 1 is negative 1. 0 of expression are the number at which the expression equal to 0. Whenever x exceeding negative 1, the expression evaluate to a positive value. Otherwise, the expression evaluate to a negative value. Okay? The previous idea can be illustrated using table of sign. Okay? So the value is the 0 is negative 1. So any value that greater than negative 1 will give you positive. Any value that less than negative 1, you get negative. Okay? So you just remember the left hand side is negative, the right hand side is positive. Okay, now suppose we have inequality of x plus 1 less than 0. Okay? When does the equality hold true? Okay? So x plus 1 less than 0, okay, require that expression x plus 1 evaluate to negative value to be true. Otherwise, the inequality is false. Therefore, we look at the set of solution will give you the negative value, or we look at the interval that will give you negative value, which is this negative infinity to negative 1. So this is the column that we need. Right? Okay. So it is necessary that inequality is written in the standard form where the algebraic expression is compared against 0. Okay. For example, ax plus b greater than 0. So solving using table of sign, write the inequality in the standard form. Okay. So determine the 0 of the algebraic expression, construct the table of sign, then find the interval with a relevant sign as a solution. okay, including zero of the expression in the solution as required. So you only need to drop down the sign, okay, no need to write the value. Okay, for example 10, okay, solving of this linear equality, okay, same thing, okay, we want to make it in the uh, standard form, so we minus both sides with x plus 1. So 2x minus x, you get x. So plus positive 7 plus 1, you get positive 8. Okay, 1 is in a standard form. So you look for the zeros. So x plus 8 equals 0. So x equal to negative 8. Then we use the 0 to construct the table of sign. So the left hand side of negative 8 interval will be negative. Right? The interval negative 8 to infinity is positive. Okay, since the equality x plus 8 is less than 0, require that x plus 8 to be less than or equal to 0. Okay? The interval at which the expression evaluate to 0 or negative value is the solution. Okay, therefore, the solution to this inequality is negative 8, negative infinity to negative 8. Okay, I want you to pay attention on this. So in your table of sign, okay, close bracket. So why this become open bracket, right? Open bracket because, right, the question inequality given to you is with equal sign, right? So your interval, right, in your table of sign, right, you can write without open or close bracket, right? But your final answer, right, must give close bracket, okay, if you have equal sign. Okay, so this one is less than equal, so you need to have a close bracket. Okay, so we go to exercise 7, okay, solve the inequality, okay, using table of sign. So I want you to try this by yourself. Okay, so this is the end of our second online class. So please make sure you complete your attendance, right? Before you study this online. Okay, thank you and have a nice day.